Okay, in day 4 notes inequalities, we're going to solve the following inequalities and write our answers in interval notation. So first thing will be subtract 3 from both sides. And then let's go ahead and divide by a -2. Remember that anytime you divide by a negative, you must flip your inequality sign. Okay, so now I have 5x plus 7 is greater than or equal to -9. Move the 7 over. So we have x is greater than or equal to -16 over 5. So if I want to write that in interval notation, we're going to have a bracket, -16 over 5, comma, infinity. Okay, so in number 2, I'm going to want to eliminate the fraction. So in order to do that, I'm going to multiply by the least common denominator, which is 6. So I'm going to multiply both sides of this inequality by 6. So I end up with 3 times 2x plus 1 minus 2 times x minus 1 is less than 6x plus 3. Okay, I'm going to go ahead and distribute. So now I have 6x plus 3 minus 2x plus 2 is less than 6x plus 3. Okay, now I'm going to combine my like terms. So I have 4x plus 5 is less than 6x plus 3. Let's move our x's to one side, numbers to the other. So I'm going to have 2 is less than 2x, 1 is less than x. I like to always have my variable on the right-hand side, so I'm just going to rewrite this as x is greater than 1. So if I write that in interval notation, I'll have my soft bracket 1 to infinity. Okay, again in number 3, we are going to want to eliminate the fraction. So our least common denominator is 12. So let's multiply all 3 parts of this inequality by 12. I end up with 8 is less than or equal to -6 times 5 minus 3 over 2 divided by 2 is less than or equal to 9. Then let's simplify the middle. So we have 8 is less than or equal to -30 or plus 18t is less than or equal to 9. Okay, let's add 30 to both sides. So I have 38 is less than or equal to 18t is less than or equal to 39. And then divide both by 18. Okay, then check to see if you can simplify anything. We can simplify the right-hand side to be 19 over 9. It's less than or equal to t is less than or equal to 39 over 18. Last step is to write that in interval notation. So I have 19 over 9 to 39 over 18. Okay, so in number 4, we have x minus 5 is less than or equal to 2x plus 3 is less than 10 minus 3x. So it gives us a hint. It says note variable is not only in the middle. So that means it's either going to be a less than problem or a greater than problem. So here we have less than or equal to and less than. So this is a less than problem. So if you remember back from algebra, less than, so it's an and inequality. So we will have x minus 5 is less than or equal to 2x plus 3, and we have 2x plus 3 is less than 10 minus 3x. So now we have two problems, two inequalities to solve. So let's solve one at a time. So I end up having -8 is less than or equal to x. I always like to have my variable on the right-hand side, so I'm just going to rewrite this as x is greater than or equal to -8. Then I can go ahead and solve the second one. So I will end up having 5x is less than 7. So x is less than 7/5. So here are my two answers. I can see, since my variable is on the right-hand side for both of them, I can see what this graph is going to look like. If you're having a difficult time with that, you can always go ahead and sketch this out. So here I would have my -8, and that's a closed circle. Here I have 7/5. That's an open circle. Now if I look at -8, my arrow is going to the right, and at 7/5, my arrow is going to the left. So I know that I am going to be shading in between. Also, anytime we have an and problem, that means that they are coming together. So writing this in interval notation, I would have hard bracket, -8, and then to 7/5 with a soft bracket. Okay, so moving to the second page, we have absolute values and inequalities. So first we have the absolute value of u is less than a. So we talked about this a little bit on the front side. So we will write that as -a is less than u, which is less than a. So this is going to be a less than problem, which is one of those and problems. And then we have the absolute value of u is greater than a. So since the greater than one, that's going to be an or problem. And we write it as u is less than -a or u is greater than a. Okay, so looking at these first two examples, we are going to solve them, graph them, and write them in interval notation. So I have the absolute value of x is greater than 2. So this is an or problem. So I can drop my absolute value sign, and I have x is greater than +2, or x is less than -2. So remember, we always have to flip our sign and then we make it negative. So if I sketch this graph, I'm going to have my -2, my +2. I have open circles, and then I'm going to be sketching out. Okay, and then if we also look at these arrows, at +2, I am going to the left, and at -2, I am going to the right. And then last, we can write this in interval notation. So I'm going from -infinity to -2, then union, +2 to +infinity. Next, we have the absolute value of x is less than 2. So that is an and problem since I have less than. So that just means I'm going to have -2 is less than x, which is less than +2. And that's how I get rid of my absolute value sign there. If I sketch this graph, okay, again, we're going to have -2 and +2. And again, we have two open circles, but this time, since it's an and problem, it's going to come together. Then if you also notice, the x is in the middle, so anywhere between -2 and 2 could be a solution. So writing this in interval notation would be -2 to +2. Okay, so in 4a, we have the absolute value of 3x plus 5 is less than 17. So since I have a less than, this is going to be an and problem. So if we follow the formula from up above, I'm going to have -17 is less than 3x plus 5, which is less than 17. Okay, let's subtract 5 from both sides. And then we can divide by 3. So I'll have -22 is less than x, which is less than 4. Okay, so if I write this in interval notation, I have -22 to +4, both with soft brackets. In part B, we have the absolute value of 3x plus 5 is greater than 17. So this is an or problem. I'll rewrite this as 3x plus 5 is greater than 17, or 3x plus 5 is less than -17. You can go ahead and solve each of these. So I'll have 3x is greater than 12, so x is greater than 4. Or I'll have 3x is less than -22, so x is less than -22 over 3. When I write this in interval notation, I will have negative infinity to negative 22 thirds, then union 4 to positive infinity. Okay, in our last example for today, number 5, we are solving for variable b. So in order to determine if this inequality is a greater or less than inequality, we do have to get the absolute value isolated. So I'm just going to subtract c from both sides. So I'll have u, the absolute value of u times b is greater than s minus c. So now I have greater, so I know this is an or problem. Okay, so I'm going to rewrite this as u times b is greater than s minus c, or I have u times b is less than negative s minus c. Okay, then we can go ahead and solve both of these. So if I'm solving for b, I'm going to divide by u. So I have b is greater than s minus c divided by u. Okay, and then on the right-hand side, I am going to distribute that negative. So I have ub is greater than negative x plus c, and then divide by u. So I'll have b is greater than negative s plus c divided by u. Okay, and then if I write this in interval notation, it's going to be negative infinity to negative s plus c divided by u, and then union s minus c divided by u, comma, positive infinity.